Hello, everyone, and welcome to Sensor Data Transformation webinar, part of our oil and gas data science and digital hub series. I'm really glad to see some familiar names here. Thank you for joining us and for your continuous support. Before we move on to the presentation, please notice our legal disclaimer. Material presented here, including but not limited to text, images, and codes, are subject to digital hub terms and conditions and are for demonstration purposes only, and may include future product features and plans. Sharing, copying, reproducing, and modifying them in any form requires Integra's permission. I'm Hoda Rezai. I'm your host today. I have Babak Shafi, our founder and CEO, and Sylvia Lee with me on this webinar. Please tune in for our upcoming webinar. We have one webinar planned on September 21st on the oil and gas IoT data X-ray. Please sign up for this event on Digital Hub website, on our LinkedIn page, and also on Eventbrite. If you haven't already created your account and subscribed to Digital Hub, please do that. It's very easy. You need to register and sign in at cloud.digitalhub.io. Then you need to be subscribed to a plan to be able to access the applications and the notebook templates. We are offering our academia plan for free to webinar attendees. If you use the promo code Join the Hub in the student ID promo code section, you are qualified for academia plan for free. After that, you need to create a project, either data exploration or machine learning project, in just a few clicks, and make sure you add Jupyter Lab to your project. And then when you launch it on the notebook templates, you will able to find the notebook that we are going to present today. Look for DHEDA Sensor Data Transformation Notebook to access the analysis that Sylvia is going to walk you through today. Please note that this notebook is available during the webinar and for a limited time afterwards. And with that, I'm going to hand it over to Babak for an interview of Integra and Digital Hub. To you, Babak. Babak, you're mute. Sorry.
Good morning. Let's try this again. Good morning, good afternoon, and good evening to people around the globe who are joining the platform, the Digital Hub. Just looking at some Google Analytics, I see people from UK, from US, South Africa, and from Middle East. So that is fantastic to see such a global adoption of the platform. Many of you have already joined these webinars, but I would like to do a quick introduction of Integra. We had a mission to reduce the barriers to adoption of AI and ML. And part of our way to reduce that was to create a community that is collaborative and shares the learnings and the development that happens in this space. And this webinar, this free webinar, is our way of giving back to the community and sharing with the community what we have learned and what we have done in the past. Some really exciting work coming up today with Sylvia and continue. So as what I said, make sure that you sign up for the events. Integra brings expertise in oil and gas. We've been in the space for over 10 years with many use cases and proven in terms of health and safety, inline inspections, drilling optimization, production optimization, pipeline failure. We know the data, we know the industry and its processes, and we're experts in data science and software development, which together has brought us together on a platform, Digital Hub, that enables the digital transformation that is going on in the industry. I do want to talk a little bit about Digital Hub. If you can go to the next slide, please. Digital Hub is a cloud-based platform. Digital Hub gives individuals the same access and capabilities as the large enterprises. Within Digital Hub, you would have access to various tools for business intelligence, business analysis, data integration, as well as data science and automated machine learning, all in one place, out of the box, ready to be used, very cost effective, with lots of expert notebooks like the one that you will see today that enables you to bypass a lot of time that otherwise you would have to spend on installing, configuring, and maintaining the packages. You could literally pick up today's notebook, use your own pump or sensor data, and start to perform the transformations. Next slide. The concept behind the digital hub comes from years of experience in this space. Our background in consulting and software development and in oil and gas. Many of these tools and capabilities today reside in different applications, and these applications are not connected and they don't talk together. As a result, the data scientist has to work in a silo, the business analyst has to work in their own silo, and engineers have their own silos of applications. For many years, these silos were related to the data, but today, with the advance of the data lakes and the cloud, a lot of this data is coming together, but there's still silos. And these silos are in the data to insight process. And the fact that many people who need to collaboratively work on the same problem have to now use different tools. Digital Hub brings the data, the machine learning capabilities, the automation, the big data, the alerting, the visualization, the insight generation, the analysis, all under the one hood, and runs on a single source of the truth and connects to a single source of authorization. So all users can leverage the same data set, have the same processes, and have one single portal to go to for their data insight generation and also the data science work. Next slide. So who is Digital Hub for? There's again big gap between the skill sets. And what we wanted to do, we wanted to bring in the engineers, the data scientists, and the business analysts together, because to solve a real world problem, you need expertise around the business and the physical phenomenon that is happening. Being a reservoir, optimization, or pump, failure, or a pipeline flow optimization, an engineer needs to be involved in laying out the meanings and the dictionary of the data, and the business analyst will be working along the side of the engineer and the data scientist to come up with these solutions. So we built Digital Hub for these three personas, and the idea is that we bring them together and make them work around the same problem a lot more effectively. Next slide. With this, I'm going to pass it on to Sylvia. I don't want to take a lot more time, but I'm happy to connect with you on LinkedIn or any other medium that you are interested through our website and different various pages that we have. We also have a community site that you can join and continue this conversation. But for today's purpose, we want to bring in a real example of leveraging data sets from sensors and harmonizing, transforming, and making it useful for future anomaly detection. With that, I'm going to pass it on to Sylvia. Thank you.
Hi there, everyone. Thank you, Babak. So today, again, our demo, as Babak says, is going to be focusing on the sensor data of the hydraulic system. So we had already done a univariate analysis of this hydraulic system sensor data from the last series. So feel free to go back on our YouTube channel there to take a look at that. But today, what we're going to be focusing on is how to join and merge all of these sensors together. So there are going to be sensors that's taken at different frequencies. So how do we merge all of these mixed frequency data together to get them prepared for our future analysis? So with that, I'm going to transition over to our digital hub here to just give you a quick walkthrough of our hub, and then we're going to go straight into the notebook and then go through the notebook together. So once you access our digital hub page, it's going to be at cloud.digitalhub.io. You're going to be brought to our sign-in page here. If you don't have an account with us yet, feel free to come in and sign up for an account. But in this case, so just a quick form here and validate your email to get an account with us. In this case, I'm just going to log in and show you. So once you're on the digital hub, you'll see a homepage here. You'll be able to access some of our past webinar series in the tutorial here, and some of our contents that we have put out together to, again, bring up this data awareness inside the community here. But what I'm going to show you is just as Holden said, you will need to get a subscription with us. So just come on into the subscription pricing page here and then choose a plan for you. So Digital Hub kind of operates on a pay-per-use basis. So you will be, for the amount of time and the amount of storage that you use on the platform, it's going to be what we're accounting for. But for every single subscription, you do get a certain amount of free hours and storage that you can use with your subscription here. So once you've gotten a subscription with us, again, with the academia subscription, you'll be able to enter in that promo code under the student ID promo code box to get a subscription with us. So after you have a subscription, if you come in and create a project, it's going to show you quickly how you can do that. So it's just quick 4 steps here. So again, select the type of project that you want to do. So in this case, I want to do a data exploration project. I'm going to select the different type of applications that I want here. To be able to follow along with us, make sure that you choose the Jupyter Lab application here. Citrus and Grafana, these are dashboarding and alerting applications that you can use on your data sets. I have a team subscription, so I'm able to add different members to my team here. So say I'm going to add Hoda to my project here. I'm going to give her a row here, say on the row. So these rows here actually do get propagated into all of the applications that you just selected in the previous screen there. I'm going to give it a name. So this is an exploration project. Here, so I can look for it later, CVDA, and then simply create a project. So now, once you've submitted that in our backend here, we're going to be launching up all of the projects for you. So what you're going to see is actually all of these applications going to get provisioned in the cloud for you, along with a centralized database that acts as the central source of the truth. And then do be aware that once your project is done provisioning, they'll be ready and up running in the cloud. So make sure that you come in and manage your applications here, whether it's to launch it, whether it's ready, or if you're not going to use one of these applications, pause it while you're not using them, so you don't get charged for the time of your application running. So that's simply on the digital hub here, but I'm just going to go straight into my Jupyter Lab here on one of my existing projects that I've already opened up. So once you have launched up Jupyter Lab, this is what you're going to see. And then to access the notebook that we're going to be showcasing, the application and the joining of the sensor data, come in on the template section here on your launcher, choose Digital Hub, and then choose the PHEDA sensor data transformation. And once you click go, you'll be brought to the notebook there. That's going to be similar to the notebook that we're going to be demoing. But for time purpose, I've already pre-ran the notebook there because some of the rendering and joining does take some time. To already pre-ran the notebook here, and I'll be walking you through it. So now we're actually at the core part here about showing the sensor data and how we do the application and joining. So again, these are sensor data. It's available on the Kaggle competition. So these are open source data set that you again can download yourself. But if you access our template notebook here, you're able to just simply run the notebook where we have the data available for you inside the Jupyter Lab here. So this whole series that we have now is on exploratory data analysis. Really, the goal of exploratory data analysis is you're able to aggregate and summarize for insights that's already present in your data set. And the other goal is to actually get your data set ready in a format that you can do further analysis and modeling to really dig for those insights that's not that apparent in the data set. So in this series, we already done the univariate analysis. So then what you can do with every single feature inside your data sets there. And then now that's the second part of the series. We're going to show how you join and get your mixed frequency data into a single data frame that you can later on do it for more regression analysis. The next section, do pay attention for it. We're going to come in with a little bit more on data, error handling, cleaning, and wrangling, and then eventually some of the regression and correlation analysis. So with sensor data that are very common and crucial in a lot of the operation system, getting a proper process in how you can handle these sensor data, they can become very valuable. And because usually they come in very high granularity and abundance, so this is where our local series coming in to show you a little bit more on the process here. So again, we're going to launch in some libraries here, and then we're gonna go ahead and join and merge the data. So in this notebook, we're going to be joining the profile data, which is going to be the conditions of the hydraulic system that's observed, one observation per hydraulic cycle. This profile data is really a lot of categorical data that really shows what the conditions of the hydraulic system is for that particular cycle. And then we have numerical data for the motor power, the volume, and the temperature, and they are at different frequencies. So the motor power is at 100 Hertz, volume is at 10 Hertz, and then temperature is at 1 Hertz. And so we're going to be showing you quickly how you can get all of these different frequencies together into a same frequency and then merging them. So here's a quick look here for you, just what it looks like for the profile data, a little bit more description on what every single feature and what the categories are in here. We have gone through this profile data a little bit more in a previous series, a section on the unit vary analysis. So feel free to go back to that as well to do some review of that. But in here, we're just simply importing the data, and I have segregated the indexes so that I'm able to know which cycles is in the stable state and which cycles in the unstable state. And similarly, you can uncomment this code cell here for generating a PINDAS profiling, so more of a UBA on the profile data here. So with the sensor data, so these are all the numerical data. If you go on the Kaggle competition to retrieve the data sets, you're going to see sensors, all of these different sensors that's available for you. But for the purpose of this notebook, where we're showcasing the joining, we're just using the motor power cycle, and then the volume flow and the temperature sensors at the different frequencies. For later on series, we're going to then look a little bit more into pressure and vibrations, which are very important measurements for us to be able to detect, say, anomalies inside the hydraulic system here. So next, I am just importing the data. So again, from the data dump of the hydraulic system, we will have a sample of the data set here. It's a text file with a whole lot of numbers. So then what it actually looks like is that for every single row, that's one cycle. And then for every single column, it's going to be the measurements inside that cycle. So say for the 1 Hertz data, where there are 60 measurements per cycle, you're going to see 60 columns of numbers and then 2,000 rows of numbers. So then once we've imported it into a data set here, this is how that looks like. So one additional step that I did here that you can also refer to a little bit more explanation in the previous section is to aggregate every single row into a single mean of the values here. So then we get for every single cycle, what is, say, this is the temperature sensor number 1, what is the mean temperature sensed from that sensor for that cycle. And we're going to be using these means here for a little bit more visualizations later. Similarly done for the 10 Hertz and the 100 Hertz data here. And maybe it's just the data scientist in me. I'd like to do some data visualizations every single time before I actually go on to do any sort of data wrangling or data analysis. So in here's just a quick plot of all of the means of the data here for all throughout the 2000 cycles. So these are the means of the motor cycle, so the motor power, volume flow, and temperatures for all the different sensors, showing how it trends over time from cycle 0 to cycle 2204. And then we can actually kind of see here that before 700 cycle, there seems to be a little bit more of something's going wrong there, but after 700 cycles, things seem to be a little bit more stable over time, even though we do have some unstable periods where it's transitioning between stable state, but overall it seems to be a little bit more normal. So this is a type of visualizations that you can do with the mean of the cycles, just getting a hang of the overall picture of the hydraulic system throughout that data gathering period. But what I also wanted to know is how does the cycle actually looks like for every single one of these sensors. So this is what you're going to see in the next graphs here, where we have the temperature, the sensors in the stable states in one column and the unstable states in another column, and every single row is one sensor. So inside each graph, what you're going to see is every single line is one cycle. And then so these are all of the cycles overlay and plot over each other. So I can kind of see what the shape of the cycle looks like for all 2000 cycles. So these are the temperature. Similarly, you can do that for the volume flow. The volume flow, there seems to be a little bit more distinct of the shape for the volume flow data here, and also very similar between stable and unstable cycles. And then same thing for the motor powers. So now that was a little bit really just a little bit more of kind of exploratory analysis on the data set that we're working with. So now we're actually going to go into the core part of the notebook here where we're joining the data. So here is a quick example of where I want to get to. So if you can remember, right now what we have is for every single every single sensor, we have a whole data frame. So what we want to transform that into is that, so for every single sensor is actually just one column inside the data frame. This is usually how a lot of the analysis will require your data set to look like. So for every single column, it's one feature or one variable inside your problem here. So to get to a final form that looks like this, what we're going to do is first go have 3 steps. So we need to convert our raw data structure, so that whole grid of our data into long form. So all of this measurement is now residing under one column. And then we need to deal with the frequency. So we actually need to downsample or upsample our data set. So then we get all of our data in the same frequencies. And then the last part is merging all the data sets together. So just converting them to long form, there's a little bit of more functions here that I can look into, but this is general what it looks like. So say for the 100 Hertz motor power cycle data here, we have 6,000 columns and 5 rows. 5 rows because I just took the first 5 rows of the data sets to showcase here. But what we're going to actually transform it into is to a form that looks like this. So all of the measurements now resides under the PS1 column. And then the cycle and attributes kind of act as the index for this data set here. So the cycle being which cycle it's at, the attributes being which measurement inside that cycle this measurement is for. So that you can see the number of rows significantly increased because now we have just transformed that whole entire grid into one single column. So doing the same thing for the temperature and our volume flow data here. Temperature, since we have 4 different sensors, so we see 4 different columns here for each sensor. Similarly for volume flow with 2 different sensors, we have a single column for each one of these sensors. So that was the first step in transforming it into a long format. So now what we have is going to transform it into the same frequencies. So now, because we have the different frequency of 1 Hertz, 10 Hertz, and 100 Hertz, what I'm doing in this notebook is I'm kind of picking the middle ground, and I want to convert all of my data into 10 Hertz. So what that means is that I need to upsample my 1 Hertz data by a factor of 10, and then downsample my 100 Hertz data by a factor of 10. So in this case, with downsampling, what I'm going to do is just using mean as kind of my aggregation method. So what that's happening here in the function is that for every 10 data points, I'm taking the mean of it, and then using that means as the final transformed value for that downsampling data set. So after we downsample, you can see that the original shape here. So originally this many rows, and then now we've reduced it by a factor of 10. And this is how the data set looks like. So you can see here now the last attributes that we have is at 599, where it would have been at 5,999 in the original data set. And also just doing a quick plot of it to look at the motorcycle power. So on the first row here are the 2 stable and unstable states of the cycles. And then down here is downsampled set. So you can see that both of them, there's no significant difference on there. So this is telling me that my downsampling is okay. So now for my temperature data, I need to upsample it by a factor of 10. So I'm using a interpolation technique here. That's provided by the pandas library. So by default, it's going to be linear interpolations. Do keep in mind that when you're doing upsampling, there's always a factor of risk and uncertainty in there. So then do be careful of it. But in this case, I'm using the interpolation technique here to upsample my data size. So just to visualize it a little bit better. So again, we have increased really our number of rows by a factor of 10 here. Making sure that it's 599 for every single cycle here. And then doing a little bit more visualization that will demonstrate that interpolation a little bit more. So then you can see that for the graphs here, we have the blue points are going to be my interpolated point. The red points here is where the original measurements are. So just looking at it for the 4 different sensors. If you have the notebook open, feel free to change the cycle number here and run it for different cycles to see how that looks like. But overall, I think the linear interpolations here seems to be working well. I think it still captures the trends quite well for the cycles here. So that's going to be the final interpolation result. So now that we have upsampled our data sets and downsampled it to get everything under to 10 Hertz, now we're able to do this final merging. So then for all of my sensors data, I'm using cycles and attributes as kind of the index for the merge because that defines the data points there. And then I've also done an additional step here where I've merged in that profile data just on the cycle here as the key for the merge. So then what that means is that for all of the measurements here that's under the same cycle, we're going to get that same profile data for all of the observations here. So really this already concludes our merging for this whole big task here. I've also done a little bit more of a feature engineering. You can reference it with this blog post here by David Calico, where I actually converted my attributes into sine and cosine, which actually just captures the cyclical feature a little bit better for later analysis. So feel free to come in and read on the blog post and then also take a look at the code here. So the last little bit is just a kind of a wrap up of this entire notebook. Have the pandas profiling here, just on the minimal version, because now that we have all of our data sets merged under one single data frame, we can now plug it into pandas profiling to give us a little bit more insights into how each of these feature looks like and getting some of the summary statistics. So I can look at the power cycle, I can look at the instant values, means, the distribution plot, temperature. And then similarly for the categorical data, this is going to look a little bit different where I actually just get a count plot of all of my categories and then knowing what the state counts and missing values are. So with that, it wraps up our demonstrations of the notebook today. Surprisingly, I'm within time. So with that, I'm just going to hand it back over to you, Babak, for any closing remarks. And also we'll open up for questions. If you early in the Q&A sections, we'll be answering them if you stay for a little bit longer. So thank you.
Yeah, thank you, Sylvia. Excellent job. We usually don't have, we can't finish it on time, but you did great. This sensor data transformation has lots of applications. So in drilling optimization, you would be dealing with a lot of high frequency data. So being able to actually sample the data set properly for the purpose of the use case that you have is really important because it does save you quite a bit on compute and storage processing. One of the use cases we had was around drilling optimization. And one of the challenges is that they had so much data, they had to actually stop bringing sensor data into their Azure platform because they just couldn't handle all the volume of the data. So with a little of work, you can optimize your data streaming and your data processing and have a place where you actually analyze. Maybe on the edge device, you can decide what sort of data or what frequency you want to bring into your cloud, and that would save your company tons of money and your data scientists tons of energy. So really important. The next session, we will actually look at this data. We will pick up the vibration data that comes from this pump. And through that process, we'll actually do some vibration analysis using the signal processing properties. With that, I want to invite everybody again to join our Integra LinkedIn page, as well as we'll put it in the chat, as well as our community, which is at community.digitalhub.io. And the last word is, as you've seen, a lot of this information is open source, and we're making this, expert knowledge available to you. We hope that you spread this, because to change the oil and gas and to bring the improvements that we want to see in this space, we need all of you. We need everybody to work together, from engineers, data scientists, business analysts, vendors, and software providers, in order to achieve that goal. So with that, we seem to be right on time. I want to thank everybody for their time and joining this event. There is a little survey. It's probably just one question that we may be popping up. So if you have a moment, just let us know if you enjoyed this session or not, and any other comment that you have, please do reach out. As usual, we will stay on the line for a couple more minutes, and just to answer any other questions that might be out there. Otherwise, have a wonderful